Okay, part 2 of the step attenuator. So, just after I finished part 1, I went in the house. What did I see? Switches on the doormat. Less than 24 hours after I ordered them on eBay. That's pretty impressive. Seldom do you get service like that. Anyway, I've now got to mark the positions for them and drill some holes. I'm not going to bore you with hole drilling. I'll come back to you when they're all done. So there you are then, switches are in. Go away wire. And that's what they look like on the back. I think they're not quite aligned, but whatever. I think it'll be alright. And the intention is to make some little circuit boards up that the attenuator elements will contain, which will contain the attenuator elements, and solder the bottom of the board, which will be earth, as in that point there, to the underneath of the box, and just wire the wires straight, these two bits straight onto those two terminals. So that's the hard bit coming up, making those circuit boards up. Not sure whether to etch them or just hack them away. It's a very simple little board, but whatever. I'll get back to you when I've had to think about that one. So this is what I've come up with anyway for the attenuator boards. I just hacked it with a knife and I got a fairly good cut. That's all I need. As I said, it's not going to be pretty. It's not going to win a beauty competition, but anyway, the series resistor goes across there. And then you've got a resistor down from there to earth, and on the other side, from top one to earth, as in the diagram, wherever the diagram's gone. And the 20 dB ones, I've got to have two resistors in series across here, so the cutout is bigger. And I don't know why I did a cutout down there. It doesn't need one, but it's there now anyway, and it's got to stay on it, because this is just these sides, both earth potential, so I didn't need to cut it down there, but what the hell. Next thing is to get the resistor soldered on. That'll be fairly easy. Do you want to see that on camera? No, not really. I'll go ahead and do that. So, boards are all done. I mean, you can just about see how I've stacked the resistors to parallel them. And I checked with a meter between there and there, and there and there. Identical readings, so the joints are good. That's the other 10 dB one. 20 dB, much the same. Resistors stacked to parallel on those two. And on this one, two resistors in series, 100 and 150. And again, check to the multimeter, symmetrical values each side, so that's fine. Just got to solder them in the case there. Well, it's another day and I'm back on this again. So next job was to solder these boards in, wasn't it? But while I'm doing that, I thought it might be an idea to solder the screening things in, whatever you call them. This is made out of very thin copper. I've got loads of it, which I bought from China for another project, and I was wondering what to use to link up the individual switches through the hole, as it were. And well, I did consider using this stuff, semi-rigid coax. I think it's a little bit over the top, and also the distance between the switches is quite small anyway. It's only about an inch, less than an inch probably. A bit over the top. I mean, it would certainly be low loss, but not really necessary. So let's throw that away. So I think I'll use this. It's Teflon, PTFE, whatever your preference. Silver plated wire, Teflon covered. So as we all know, silver has got the lowest resistance, and high frequencies, you're talking about skin effect as well. I think this will be good enough anyway, and I've got plenty of it. I won't need that much. So let's get soldering off camera, I'm afraid. I might have to use the gas iron for this to heat up the metal with the blow lamp attachment. We shall see. Might do it with the Weller, see how difficult it gets. That's the little blow lamp attachment. Right, I'll come back when it's done. So that all went extremely well. As you can see, I managed to easily solder those boards and the copper screens using the good old Weller. Didn't need a blow lamp after all. As you can also see, there's a little bit of a gap between there and there because of the box that goes on top. Zoom out. So that's how it'll be, and depending how well it works, might go along the seam with the soldering iron, but we'll worry about that later. At the moment, I'm going to get all this sellotape off, and really the next job is just to wire it up, which is fairly tedious stuff. So I'll come back to you when it's all wired up. Okay, oh, it's cold in here. Temperature 13 centigrade, 55 Fahrenheit for Joe's benefit. And it's almost to the point where I need heating on. But anyway, this is what I've got to, and everything's wired up in the switches. If you can see the shorting links, which are, that's no good, I need a better pointer. I actually found some offcuts of copper, which is like this, from that copper sheet, which was ideal for wiring across the switch contacts. Similarly on the boards to the switches, I've used that. It's better than wire, I think, and done the inside. So I've only got to wire the sockets up. There'll be the dreaded testing of it. It'll either be a disaster or it'll work quite well, and probably somewhere in between. Anyway, I'll just wire the rest of it up. Okay, it's time for testing. I've got the spectrum analyzer set up, and I'm using the built-in tracking generator, which is over there, button, and I'm sweeping between 0 and rather optimistically 200 megahertz. And at the moment I've just got a through connector to basically set myself a reference. So I've eliminated the losses in the cable basically. So let's connect. First of all, we're going to have it in the all switches off. So straight through. See what the through loss is. Connected up. Ooh, okay. Well, we go down here. 18 megahertz, 0, no loss at all. Gradually going up. 50 megahertz, 0.07 dB. That's not bad, is it? 60.2. Let's take it up to 100. 100 is 0.8. So really that's your limit, isn't it? You've got nearly a dB of insertion loss, and that rises a bit more up to 200, 1.2. Okay, back down to say let's say 10 megahertz, and now I'll switch in the first 10 dB pad. Not bad at all. Not bad at all. I think what I'm going to do is I'm going to reconfigure all this to go up to 100 maximum, because it's not going to be usable really above 100. So stand by. So I've just reconfigured everything, so we're now going up from 0 to 100 and plug it back in again. Switch in 10 dB, and where's my marker gone? Yeah, so really we're pretty damn close, aren't we, to 10. 10.12. I don't think you could do much better than that as an amateur, unless you fiddle around forever. And really it's only down to the insertion loss that affects its attenuation as you get higher. So that one is good. That's the first 10 dB. Let's check the next one. I think we're going to find that it's going to be almost exactly the same. So we're up at 450 megahertz, 10.1. So certainly a decent attenuator up to 50 at least. Right, let's try one of the 20s. Quite impressed with that. I mean, here we are, 50 megahertz, and we got 19.9 something or other. I mean, you couldn't get much closer than that, could you? For something you built yourself. I think that is extremely acceptable. Let's try the last 20, the other 20. Exactly the same. So, pretty impressed with that. Take it right up, and you get a bit of loss, through loss. Okay, so now we can do the next test, which is 10 plus 10, let's say, which will give 20. That's not far off 20. 20.2 at 50 megahertz. And then we can use a 10 and a 20 to get 30. 30 is pretty good. Oh, you couldn't get much closer than that, could you? Okay, we're not up at super high frequencies, but it's still good. So that's 30. Now we want to do 40. So that's two 20s. 40. Now we're running into a bit of problems with the spectrum analyzer, because we're the dynamic range is compromised by the internal attenuator. So I'm going to get rid of some of that. Let's take it down to 10, back to marker. So 39.6 ish, pretty impressive, right up to 100 megahertz, 39.5. So it's almost usable, but beyond 100 I'd say. So what have we got now then? 40. So we need to add another 10 to try 50. And again we're running into limitations on the spectrum analyzer here. Amplitude, attenuator, that gives me more dynamic range. And 50, not quite so good. A bit more frequency dependent, but down the bottom end it's very, very close. Around the, as you go higher, higher and higher and higher, well, we're getting to about 49. Suppose it's still usable, but of course we've got all those losses through the box, haven't we? Apart from, it's not the pads themselves, it's the actual wiring in the box. So the final one is 60, so I had another 10. And that really is looking a bit rough. 57, I mean it's still not too bad, but not great, is it? 50 megahertz. I don't know if I can clean that up any more than that. Bandwidth. I don't think that would help. Might do if I can. Yeah, that'll clean it up a bit. 58. Knocking the camera. 58 dB at 50 megahertz. Yeah, so it's a little bit under what it should be. That's interesting. But I mean, down the low end, oh, it's not far off, is it? 10 megahertz, 59.5 dB. So what do we conclude from all this then? That I've built something that's fairly usable at low frequencies, but at, let's say, 90 megahertz. 57, 3 dBs out. For an amateur I suppose it could be quite usable, but it's not up to my standards of precision. And really I think it's just down to the construction. I mean, it isn't perfect. I'm lacking light here. I think the main problem is going to be losses in these bits of wire and the switches themselves, which are only basic toggle switches. They're not designed to pass radio frequencies through, are they? And if I was going to do it properly, I'd probably do it with relays, but that would involve having power on it, which would be annoying. But that's really the end of the video. But it's still quite impressive what you can make if you're careful. I don't think it's going to benefit at all from soldering the seams together. I think that would make no difference whatsoever. Anyway, I think that's the end of this video. Please comment on it, and thank you for watching. See you in the next one, whatever that might be. Bye for now.